variation of conductivity and molar conductivity with dilution. Uh, what is this conductivity? What is conductivity? What is molar conductivity? We need to know all these things, right? So, conductivity with dilution is your topic of discussion. But first, we need to know what is conductivity. Conductivity is given by the symbol kappa, and it is the ability of a solution to conduct electricity. How much of electricity the solution is capable of conducting. Now, conductivity decreases with dilution. That means if I decrease the concentration, if the concentration decreases, then conductivity kappa will also decrease because it decreases with uh, dilution. I mean, decreases on dilution. So I can say when concentration decreases, dilution increases, right? What is dilution? Dilution means adding water. And when I add water, the concentration of the solution decreases and kappa is decreasing because ability of that solution to conduct electricity decreases. Now, some may think that, okay, if the dilution is increasing, water being a polar solvent should actually increase the conductivity or the ability to conduct electricity. But here keep in mind that when I dilute, the number of ions per unit volume decreases. This is something which is very important. That is, number of ions per unit volume. Number of ions per unit volume actually decreases when you undergo dilution. When you undergo dilution, that means when you add more and more water, then the number of ions per unit volume decreases, for which what happens, these ions are responsible for conducting electricity. So the charge carriers decreases and the current flow also decreases, right? Now, even though ions can move more freely, that is what I have said, that at times people have this concept ki, okay, I am adding more and more water, the ionic mobility is increasing, but there is a drop in the ion concentration. Why? Because same thing, keep in mind, number of ions per unit volume decreases. So there is a drop in the ion concentration, for which there is a fall in the conductivity. So if it decreases on decreasing concentration, obviously it has to increase on increasing concentration. So if I increase the concentration, then more ions per unit volume will be there. Ions are the charge carriers and greater will be the conductivity. Next, molar conductivity lambda m versus concentration. Capital lambda m versus concentration. So, what is molar conductivity? It is the conductivity of all ions produced by 1 mole of electrolyte. Right? So, here lambda m is equal to kappa into 1000 by C, where C is the concentration in mole per liter. So, C is the molar concentration. Kappa is the conductivity. Lambda m is the molar conductivity. Next, molar conductivity lambda m increases on dilution. So, dilution means concentration is decreasing. Then lambda m, when concentration decreases, lambda m increases. Why is it so? See, lambda m depends on kappa and volume, right? So when I undergo dilution, there is a decrease in the concentration, then the value of kappa decreases. And when I'm diluting, volume of the solution is increasing. Keep in mind that the increase in the volume of the solution is actually superseding the decrease in the value of kappa, for which lambda m increases on dilution. So it decreases with increase in concentration. So opposite to the increase in concentration, that is decrease in concentration, is dilution. I can decrease concentration by diluting. Now there are two types of electrolyte. Right, one is the strong electrolyte and the other is the weak electrolyte. So for strong electrolyte like HCl, like NaCl, the other strong electrolytes, there is a gradual increase in the value of lambda m with dilution. So what happens is, if there is a plot, if I can plot lambda m versus the concentration factor root c, then we will see that this is the nature of the plot for a strong electrolyte. Why is it so? Because when I move from right to left in the concentration axis, that means I am decreasing the concentration, and if concentration tends to 0, then that is called infinite dilution. That is called infinite dilution. Right. So actually, and that is denoted by lambda m naught, the molar conductivity at infinite dilution. So here, if I decrease the concentration, the nature of the plot is seen, it goes up, right? The value goes on increasing. So there is an increase in the value till this point where it can actually meet the lambda m axis, where concentration becomes 0, and this is the point which we will say is what it is, lambda m naught, the limiting molar conductivity. That is lambda m naught. This is the limiting molar conductivity. Now this is limiting molar conductivity. Okay, so what does it imply? It implies that when concentration tends to 0, then lambda m tends to lambda m naught, and that is known as limiting molar conductivity for a strong electrolyte. It is meeting at this point, and so this is the value of lambda m naught for a strong electrolyte. So we can see from the nature of the plot for strong electrolyte, on increasing dilution, the lambda m value goes on increasing. Right. So why is it so? Because of reduced interionic attraction, increased ionic mobility when on dilution. Okay, so when you dilute more and more, the interionic attraction decreases because of the polar nature of the solvent. Now increased ionic mobility, that means ionic mobility also increases on account of the polarity of the solvent. But for weak electrolyte like acetic acid, keep in mind one more thing, that acetic acid CH3COOH is a weak electrolyte, but CH3COONH, sodium acetate, is a stronger electrolyte. For weak electrolyte, there is a sharp increase with dilution. Why? Because degree of ionization, this increases significantly and more ions are produced, which gives rise to a huge value of lambda m. But keep in mind that this, on dilution, the conductivity decreases. On dilution, the conductivity decreases and molar conductivity lambda m increases. So let us see the graph inside what it is. Okay, the graph inside says what? The graph inside says that kappa versus dilution is a downward curve. Let us see. Let us see what it is. See, if we see here, if for a strong electrolyte KCl, see the nature of the plot. Now, if I extrapolate it, then extrapolation means extending it backwards. If I extrapolate it, then it will meet at the y-axis where the concentration factor is 0 and there is a value for the lambda m, and this is your lambda m naught. Here is the value of lambda m naught. So this is for strong electrolyte. What about weak electrolyte? Acetic acid is given as an example. There is a steep rise. We can see here there is a steep rise. But what happens? It runs parallel to the y-axis. So it will never meet the lambda m axis. Right? So there is the limiting molar conductivity for this weak electrolyte lambda m naught is not possible to be calculated graphically, right? So there is an equation, a mathematical relationship for strong electrolyte. For strong electrolyte, there is a mathematical relationship which is given by Debye Huckel Onsager equation. Debye Huckel Onsager's equation. So this equation says lambda m is equal to lambda m naught minus b into root c. This is the expression where lambda m naught is the limiting molar conductivity. This is the limiting molar conductivity, and this lambda m is your molar conductivity. B is a constant. B is a constant that depends on nature of solvent and temperature. This is a constant that depends on nature of say solvent and temperature. So this is it. Root C is the molar concentration factor. So this is the Debye-Huckel Onsager's equation for strong electrolyte. Now we can see over here again the molar conductivity lambda m is increasing. What is happening over here? Why? Because this is increasing on dilution, with dilution. So more ions increase conductivity, but crowding of ions reduces molar conductivity. Right. So this is again another factor to keep in mind. Now dilution spreads ions apart, reducing the conductivity. Why? Because number of ions per unit volume will decrease in that case, but it enhances the effectiveness per mole. So the lambda m value will increase, though kappa kappa decreases, but lambda m value has to increase. So dilution decreases total ions per unit volume. So kappa is decreasing, but increases effectiveness per mole. So lambda m is increasing for specially weak electrolyte. For strong electrolyte, we can see there is a steep rise. So this is the overall plot showing conductivity, molar conductivity. You may be given the plot may be given and you may be told to explain the trend. This plot also explains the trend of decrease in concentration and affecting it with lambda m, how lambda m is getting affected. So till this, in the next module, we'll discuss about Kohlrausch law.